Illumination Engineering and Electric Utility Services. Today we take up lecture lesson 19, which is titled Lighting Application. Having gone through the need for lighting, how artificial lighting has extended our activities round the clock, which used to be only confined to sunrise to sunset, has evolved, and we have seen what are the various applications that could be physical phenomena that can be used for artificial lighting, and as a result what are the components of the lighting installations, how we quantify these, and how one calculates. And we had also had a look at various recommendations for both interior lighting and exterior lighting. And in fact, today we are trying to address or summarize all these things in one thing called as a lighting applications. And in principle this could be a very vast topic. There can be n number of lectures. We are trying to have a brief overview in a single lecture, and therefore the instructional objectives could be: list the various lighting applications, they understand the need to integrate lighting with other applications. As I have been all the time emphasizing right through the course, that lighting, which artificial lighting, is invariably employing electrical energy, and electrical energy is used for other applications too in our environment, and therefore there is a need to integrate lighting with other applications. That is what we understand here. And further, the lighting per se could be for industrial applications, so it's classify the industrial lighting, classify office lighting, and list requirements for lighting for educational institutions, auditoria, hospitals, hotels and restaurants. In that sense, one may say that if we had a look at the instructional objectives, we are not trying to take exterior lighting anymore into account, because we have extensively covered by way of two lectures, one meant for sports specifically, other meant for street lighting. Here the interior lighting basic principles were introduced in an earlier lecture. It must be mentioned that most of these recommendations have been based on the international recommendations based on CIE, and in all countries they have the local standards which adapt the CIE recommendations. Similarly, in our country we have the Indian standards which are specified by Bureau of Indian Standards, and this lecture at some point would like to give you an idea of few of the standards that are applicable for various lighting applications, not very exhaustively. In fact, it gives the broad number, and some of them have more than one part. The idea is to make the audience aware of the standards available, but details can be obtained from the handbook of Bureau of Indian Standards. Coming to the lighting applications, let us take the first of its kind, one of the most important things, the industrial lighting. Industrial lighting has been a very important issue because, as we have been telling, trying to make the activity round the clock, we are able to have more production. That is one important thing, and therefore there are various types of visual tasks. And unlike offices and schools, where essential task of reading and writing is the major task in most of the schools and offices, and requirements are quite different compared to what you have in industry. Industry, there may be precision production. So there could be extremely small objects in industries dealing with large scale integration, to a very large object where industrial products are being developed, or conventional engineering industry. It could be dark or it could be light components, and there could be surfaces which are regular, irregular, they could be flat or contoured. So all these things make the lighting requirements quite different, and in fact this would form one class of interior lighting, and in fact we did mention the kind of lamps that are used invariably wherever the color rendering is not very important. We try to use where the bays are very high, we use sodium vapor lamps which has a characteristic orangish color. Now here the tasks are graded depending on the degree of fineness, that is the precision that is involved, whether it is a micro component or a macro component, depending on that in the industry. Less critical you can do with low level low quality of light, whereas fine work like PCB soldering, high level with minimum glare, and invariably in such fine work environments there is a supplemental local lighting or specific lighting. As we have been telling, this is in addition to the general lighting required for the movement of the people, and hence, as emphasized several times, the lighting requirements are dictated by the nature of work, shape of the space, and the ceiling structure. Actually, we are quite familiar, quite used to having lights being brought from the roof or the ceiling, and any light which goes to the ceiling, if not fully reflected, goes waste. So the ceiling structure makes a lot of importance. And secondly, we said to the extent possible, the way we design the openings and what you call the glass area of windows, such that we avail the natural daylight available to a very large extent. So the classification could be, for an industrial thing, a single story without any skylight, meaning this fully enclosed environment which entirely depends on the artificial lighting. As opposed to this, you could have a multi-story, that is number of levels are there. Large industries invariably have various levels. So it is quite possible that some portion in the interior may not have access to the natural light in any manner. Then you have single story with skylight, without skylight, and with skylight. And lastly, you have a very high bay industries where large industrial objects are produced. Now single story without skylight, normally you have workshops, factories, and they typically have floor to ceiling heights varying from 3 to 7 meters. This is the typical workshop for small products. 3 to 7 meters is the height, and at such low this thing, and where in fact the color rendering becomes important, possibly the production is involved is with small components, it's preferable to use fluorescent lamps, and which are mounted anywhere up to the height of 5 meters. We have been talking about the various ways they can be mounted. One is a surface mounting, the other is recessed, and the third is a suspended. Suspended mounting used to be the conventional thing when the roof heights were very large, and they could be placed in a continuous or broken rows, or as discussed in the last lecture, it could be in a matrix where, depending on the what we call the room index, we could have in the form of a matrix. Ideally, it's believed lamps when placed perpendicular to the plane of work, they give a good effect, and they could be either directly mounted or suspended. As I said, they could be recessed in the ceiling, and ceiling is invariably made as reflecting as possible. The moment this height exceeds 5 meters, we use the discharge lamps. Earlier it used to be mercury vapor lamps, but you know that mercury vapor lamps have are being fast replaced because of the low utilization efficiency factor compared to the sodium vapor lamps by sodium vapor lamps. And the two categories of lamps which are often used these days are either metal halide lamps, which have good color rendering compared to mercury vapor, and sodium vapor with reflector luminaires. And typically the separation between two such lamps is maintained around 1.5 So, no matter whatever the lamps may be used, they all are discharge lamps, fluorescent or mercury or sodium. Therefore, they will need accessories which we have discussed, starting devices, the current limiting devices, they are arc discharges, and as mentioned, luminaires are best mounted perpendicular to the workbenches. That gives the best this thing without forming. And in order to have good illumination, it is necessary how the control is done. Control essentially means the way of operating these lamps. They are all electrical, they need to be connected by the cables or wires and needs to be switched on or switched off according to the requirements. So, there is a trunking system used which enables efficacy of illumination, and hope we believe in the next half of the course where we talk about the illumination utility principles, we would cover more on the way it is done. If you consider the multi-story, there could be smooth white ceilings with ceiling height ranging between 2.8 meters to about 3.5 meters. The roof itself acts as an extended reflector, and it is adequate if you have tubular fluorescent lamps, continuous or broken rows. And in fact, it must be mentioned here that these particular kind of a low height industrial systems are no different from general offices in that sense, except that if the fine work is involved, the level of illumination required may be higher. And as already told, these could be clean rooms, or they may be need to work in a dust-free environment, and in doing that controlled environment where temperatures and humidity needs to be controlled, which is often done using the air conditioning system. And therefore, there is a need to see the the heat radiated is integrated, because if you use a lot of heat radiated in the room by way of illumination, it adds to the air conditioning load. So, there is a need to integrate. This is what we meant by calling it as integration of the systems in a illumination of interiors. Now, coming to the single story with light, this shows a typical picture of a typical industry having a roof which is provided with skylight. And here what we observe is a sawtooth roof, and so that way the advantage is that from the roof there will be glass windows in a sawtooth fashion, which enables quite a bit of natural daylight available, and therefore the artificial lighting requirements may be less. And here, as has been the case with other types, a reflector type luminaire in a row perpendicular to the workbench. As already told, any light going to the roof, unless roof is very well prepared white surface, will lose the light that is going towards that, and therefore either the roof should be made with good reflectance. Alternatively, we use luminaires which come with have good reflectors. In fact, sodium vapor lamps and the metal halide lamps, they all come with inbuilt reflectors. And if you take the modern energy saving fluorescent lamps, which are luminaires, they come with what is called as a mirror optics. There is a mirror kind of a reflecting surface behind inside the luminaire that ensures that no light goes towards the upside, and most of the light is directed downwards towards this star surface. Coming to the high bays, what do we call as a high bay? High bay is base where the height is more than 7 meters, and it becomes necessary to mount at higher heights. Here I must remind once again the concept that illuminance at a surface due to a point source varies with the square of the distance to the point source location, whereas in the case of a line source it varies inversely with the distance, and in the case of a large sheet of light it will be independent. So that is how we say that sources need to be mounted higher. This is one thing. So whenever, what could be the other reason for us to mount at a higher height in high bay industries? It's possible that there are large objects which need to be moved around, and in case you need to move such large objects, they should not come in the way. Okay, so that's what we write as to avoid obstructing guide rails of cranes and tall machinery. This again becomes integration of lighting systems with the building systems in the interiors. So this is what we mean by integrating various systems. This is a part you will have if it is an industry involving with gas manufacture or gas plants. So the gas handling systems, you have cooling systems, heating systems, all. So there it's believed that you have dispersive narrow beam reflector luminaires with metal halide or high pressure sodium vapor lamps which are color corrected. Let me re-emphasize that the addition of halides in the mercury vapor lamps has enabled us to improve the color rendering ability, and they are what we call as a color corrected lamps. So what do we mean? We mean that anything having heights, ceiling heights more than about 7 meters in an industry is what we call high bays, and high bays, because of trying to integrate with other resources, other services like provision of cranes and movement of machinery and avoid obstructions, we try to have high bay lights. And in that case, as I was telling you, if one needs to have good illumination on the work plane independent of the mounting height, the best thing is to do a matrix of lamps located within a luminaire. Don't have a single lamp. If you have a point source, we know that the illuminance varies inversely with the square of the distance. If you have a line source, which is the fluorescent lamp, it's going to vary inversely with the distance. And if it is a matrix of lamps forming a what you call a sheet of light, it will be independent. Now there could be some special tasks in industrial environment there we know a lot of visual requirement, and this would require some kind of a control, because depending on the operator the requirement levels vary. Unless, I mean, the designer can provide, there are recommended levels designer can provide, but then actual requirement is can be known only by the operator concerned, and there is always a need to, depending on the type of product, to get the details to the best of the ability, and there is a need to create appropriate background. Therefore, their level also may need control issues, and this is where I say we come back to that concept of what is called as a general lighting together with what is called as local lighting. In fact, the statement says lighting, general lighting will not completely meet these requirements and additional aids are employed. What do I mean by additional aids? Additional aids are in the form of a local lighting and plus the ability to control. These could be in the form of an illuminated magnifying glass. All of us have visited at one time or the other a dentist's office, where we do find that in order to look into the tooth crown, the dentist uses specific light which has got a magnifying lens, so that you are able to, or at times when you need to observe objects in motion, you should have a lamp which has the radiation oscillating at the same frequency as the movement of the object, and this is what we call as a stroboscopic lighting. In fact, most of us electrical engineering students, we are aware when we are doing experiments in the electrical machines laboratory, in trying to study a synchronous machine, we use a stroboscopic lamp to synchronize with the frequency of the system. The monochromatic light, glass and ceramic manufacturers do need monochromatic light, and all these are the special aids that are employed in addition to general lighting, in an industry. So we have seen the industrial lighting requirements, and we say that the low height industries lighting levels, lighting concepts are somewhat similar to what we have in the offices. Now coming to the office lighting, we have the three categories which come up. The general offices, large offices where several set of people work together. Private offices, which are the top level executives who need some privacy, confidential discussions go on. Conference rooms where large discussions are held. Each of them have their own requirements. But unlike the industry, the visual tasks are well defined. They involve reading and writing, and these days, of course, operating a desktop computer. Typically, in all these applications, the work plane is around 0.75 to 0.85. That's why one could see that most of the commercial packages available for lighting calculations assume a work plane around 0.75 to 0.85 meters. The only situation where the work plane is assumed to be vertical for interiors is in a classroom for the teacher to write on a chalkboard or a screen. Otherwise, most of the thing. And all these offices invariably these days are having ceiling heights within 2.8 to 3 meters, and therefore illuminance levels, if you see, a small office may have somewhere between 500 to 750 lux on the task, which means it could have, depending on the number of tables located in the office, some kind of a local lighting which provides on the work tables around this, with a general lighting of about 300 to 400 lux in the room. The large offices, this could be more, and as already told, in the industrial lighting, the lamps could be in the form of a row continuously, or best is, as we discussed in the last lecture, in the form of a matrix decided by the room index, which depends on the room width, length and the height. And large offices, the requirements can go high, anywhere from 750 to 1000 lux. Where is this? This is the recommended illuminance on the work plane. Now there is a further recommendation. In fact, I was telling that in small offices there could be a general lighting of about 300 lux. In fact, here the recommendation says at least 50% of task illuminance must be there, with a minimum of around 400 lux. That is what we say. Apart from specifying luminance levels are also specified for the lamps. The walls are expected to have lamps, and the surfaces walls are expected to have 50 to 150 CD per meter squared. Now, this is an indirect way of specifying your reflectances. In fact, we have seen how the reflectances are specified in the last lecture on lighting calculations, where we said the very low reflectance is tolerated on the floor and very high reflectance is expected from the ceiling and reasonably high from the walls. Ceiling is expected to have 100 to 200 CD per meter square. Tasks or task area should have 100 to 300 CD per meter square. And one important issue which was not so very important in a high bay industrial environment is color appearance. Color appearance in an office environment needs to be agreeable. In fact, unless it is there, it will not produce the required efficacy in working. And often, therefore, the most common lamps that are used are what we call daylight fluorescent lamps. We know fluorescent lamps are those lamps which use the ultraviolet light using the fluorescence principle into the visible spectrum. They have lowers that which basically direct and diffuses, which disable glare. In fact, we know that the glare levels are much lower in fluorescent lamps. No doubt the CFLs have a little higher glare level than. The general offices, they are moderate to large area and work planes are not well defined. The tables could be not fixed. They will be moving. If you take a classroom, desks and chairs are fixed. But in large office, the table location does change. In this case, the kind of a thing that is employed could be ceiling mounted or recessed luminaires, which are arranged in a regular pattern, and perpendicular to the work plane is a very good way of providing the light, but then it may not be assured that the table would be located all the time that way, because it is not fixed in a large office. So some of the large offices do adapt alternate rows perpendicular to one another. It is a matrix of lamps located, and invariably each luminaire has more than one fluorescent lamp. In early days it used to be twin lamps, and these days we do have 3 fluorescent lamps placed together. And in fact, from point of view of energy saving, the trend these days is to use compact fluorescent lamps in the luminaires, and this has to be combined with, as always I have been emphasizing, the air handling system, and this air handling system should also enable in ventilating these luminaires, so that there is no undue heat generated in these luminaires, which adds to the air conditioning load. And in fact, when the ceiling heights are very high, we adapt false ceilings in which these are recessed, and false ceiling themselves are made with good reflectance levels as close to pristine white as possible. As already told, the energy saving is obtained by having required level of localized lighting with controls. Controls could be using power electronic switches, which could be conventional or these days power electronic, but all the time keeping in mind the comfort of the operator eye and the recommendations which have been laid as per the CIE. One has to, the early days it was only reading and writing, but these days, as I was mentioning, you have desktop computers, or if you are in the laboratories, you have oscilloscopes to observe the signals. The monitors, which are basically visual display units, there needs to be special care, and already as mentioned, windows and the sources should not reflect on the screen. Once they reflect on the screen, they try to give. So in fact, it is advisable to provide proper interiors or drapes along with the windows to see that you do not have such reflections. And it is believed a illuminance of a light located in the opposite direction of the screen with a level of about 400 lux is recommended. If the screen is very dark, one could have about 700 lux, and a similar requirement is used for private offices and conference rooms. Private offices invariably would mean office of a particular executive. It may mean it could be small, so there could be a fixed location for the table, and therefore local lighting could be fixed and arranged accordingly. Drawing offices are maybe obsolete these days with the computer drawings coming in, computer design coming into picture, but these were the offices which were used in earlier days to produce drawings, especially in engineering design offices. There, in view of the pencil task that is involved in drawing, a minimum of 1000 lux is recommended. Coming to the next important area is educational institutions like ours. Educational institutions, the writing, reading, is the major task, and reading blackboard, though it says blackboard, these days it's green board or white board, any of these boards, and this follows typical office lighting principles with an additional light provided over above the blackboards or the chalkboards or the screens. Basically, they need a vertical illuminance on the board, and once it is placed right above the board, it enables the glare-free observation. Typically, such an environment, the recommended illuminance levels are to be between 300 to 500 lux, and if you are having handicrafts rooms, in fact, because there are some vocational training in educational institutions where children are made to do some work experience kind of activities where there could be handicraft training there, because it involves, could possibly be involving precision task, a higher level of illuminance between 500 to 1000 is recommended. Laboratories once again will involve critical observation and therefore are maintained within those levels. Of course, optics laboratories depend on the kind of experiments they have, kind of optics they have, special lighting, and there are recommendations available for those things. As already mentioned, the vertical illuminance is required on the screens or the blackboards or chalkboards, and the level is similar to what is expected on the horizontal illuminance in the task plane in a classroom, between 300 to 500. This is about the educational institutions. Coming to the auditoria, auditoria are used for observing large presentations. So there is some minimal lighting required when there is a projection going on, and in fact that is how this recommendation does talk of having 50 to 150 lux during the projection, so that the audience do not get distracted by the activities around and they concentrate on the screen. Otherwise, there is a general lighting requirement of 300 to 500 lux, and oftentimes you think of having dimmability, in which case you cannot use fluorescent lamps. One may have to use metal halide lamps or incandescent lamps. The recommendations for auditoria, therefore, if involve reading and writing, around 500 lux, and there should be adequate glare to prevent glare, and one has to remember auditoria would also mean a room, classroom accommodating large number of people, which would amount to having to take care of the public address system or the sound systems. So both have to be integrated together with the air conditioning. So there, in fact, as I was mentioning a little while ago, dimmers, in fact dimmers, as we said in a previous class, could be in a simple sense a auto transformer, because it is an AC voltage which is being used. A auto transformer is a way of producing variable AC output, and that is how, in fact, these auto transformers were at one time called dimmerstats, because they were first developed for lighting applications where the dimming was required. So you have a local lighting on the screen with centralized controls required, and there, in fact, the best thing to enable speaker, the control panel for this should be accessible at the rostrum, so that the lecturer has, or the speaker has, complete control over it. Now let's look at the commercial thing, where shops and stores, I have categorized the general lighting. In fact, if we talk of a large shopping center, should have 500 to 750, whereas other areas, that is the corridors, the circulation areas, it can be around 300 to 500 lux. Local lighting, where do you need local lighting? You need local lighting in the shopping windows where you want to highlight the new products, you in fact have as high as 1500 to 3000 lux. When we mean other areas, the other areas include smaller shopping malls in the neighborhood, larger shopping centers. Showcase or windows, again you see general lighting is around 1000 to 2000 and 500 to 1000, because showcase is one thing which brings the clientele to the shopping area. So we see that the levels required are much higher, and of course all of us are aware that the modern shopping centers are glittering with a lot of illumination and a lot of energy that is spent there. The showcase, as already said, brings out special features of the product, and therefore the kind of lamps that are used are diffused fluorescent lamps are used. If you're having a hardware, you use diffused fluorescent lamps. Jewelry is one place where in a showcase you would always use incandescent lamps to take the advantage of its continuous spectrum and ability to have good color rendering. So that's about the shopping and things. Now next comes the hotels and restaurants. See, approach, if you see hotels and restaurants, the whole lighting can be categorized as into the approach roads, entrance, car parks. They are normally use what are called as the columnar lighting with horizontal this thing of 10 lux, or a canopy lighting with 100 lux. These are basically those post-op lanterns we were talking about. We had seen a picture earlier. The heights could be anywhere from 30 centimeters to 12 meters high, and in fact some of the outdoor gardens we have seen small low height lanterns employed. The entrance halls, foyers, they need to have lighting so that people are drawn to the reception desk, and therefore dusk needs more increased illuminance around the reception than the general lighting in the foyer. It should be completely flexible. Coming to a restaurant, you could have the fluorescent lamps all around the dining area with local lighting at tables. In fact, some of the restaurants, people would like to have dim lighting or low level lighting all around with locally higher lighting so that you see what you are eating, and this could be at lower. Therefore, there should be provisions for dimming and switching, and therefore it's observed that in order to have dim light levels, the average illuminance that's specified is as low as 100 lux. However, the cashier needs to have good illuminance to be able to, so he may have a desk light which is around 300 lux. Corridors and stairs should have the artificial lighting. In fact, as I was telling, as it was in the case of tunnels and closed corridors, even during daytime you need higher illuminance levels. So you see that recommendations are you need about 150 lux during the daytime, whereas it's only 75 lux during the night. This is essentially to enable our human eye to adjust when coming from outside. Nighttime it will be dark, so and this apart, all night pilot lighting is required in a hotel to direct, and emergency lighting is obviously there required for evacuating. If you consider the rooms or what you call as a bedrooms, general lighting, there should be a reading lamp at the table, there should be a bed head reading lamp, and wall brackets are mounted reasonably high for general lighting. So this is a typical bedroom in a hotel we are talking about. So hotel, we have seen there is a need to have some approach lighting, and which is normally in the form of post-op lanterns. General lighting in the foyer and entrance should have a little increased illumination to attract towards the entrance. Then reception desk is necessarily should have more lighting, and the coming to the restaurant, you have the perimeter of the dining area could be with fluorescent lightings giving some average illuminance levels of about 100 lux, with some local lighting on the tables to enhance and able the diners to see, observe what they are eating. But cashier certainly needs very good levels, at least around 300 lux. Now this apart, the hotel should have pilot lighting. Pilot lighting is basically trying to say direct which way the rooms are, and emergency lighting for evacuation. The coming to the rooms, which is termed as bedrooms here, is the main occupant rooms in a lodge or a hotel. There should be general lighting, reading lamp at the table, bedhead, reading lamp, wall brackets should be mounted high, and the mirrors should be provided with fluorescent lamps right above, if not on either side. So this shows a typical hotel room. As you can see, there is a standard light provided for general lighting. There is a table lamp provided on the table to the left corner, the top, and there are two bedhead lamps on each of the bed, and there is a mirror located to the right towards the bottom. There is a fluorescent lamp placed on top. So this is how, as recommended in the case of a hotel, one does lighting. Now let us look at another application, that's the hospitals. The hospital lighting involves three categories of users, that is the patients who need to relax and recoup, technicians who need to perform certain tasks under the supervision of doctors, third, the doctors. In these lighting, color rendering is important because if there is any change in color, one may misdiagnose a disease and it could affect the psychology of the patient. So the radiation is sometimes employed for treatment, so it should be interference free. These are some of the issues. So considering all this, one has in a patient's room a general lighting varying from 100 to 200 lux, whereas a local lighting required for the technicians and doctors around 100 to 300 lux. Luminance at no point not greater than 350 CD per meter square. The examination lighting, yes, when examination lighting requirements are very high, it can go up to about 1000 lux. Night light should be around 0.5 lux. Night observation light in the nurse's station could be around 5 to 20 lux. Corridors, as already told, daytime you need higher levels, that is 200 to 300 lux, whereas night time it could be around 5 to 10 lux. Examination lighting is necessary because it could be an interior examination, and these are in fact may be provided with magnifying lenses. So that being the case, examination rooms are invariably provided with what we call 4000 K fluorescent lamps with 500 to 1000 lux. Theaters, that is theaters here mean operation theaters, should have shadow free lighting. ICU and X-ray rooms can have low level of lighting because it's mainly for the X-rays should not be exposed to any light, whereas ICU, the patient needs good recovery, relaxation for recovery, 10 to 30 lux. Now here, having covered all these recommendations, it's felt that let us have some look at some of the luminaires that are there for these lighting purposes. The picture out here shows decorative luminaires which are called surface mounting luminaires, as can be seen. The top one is a circular one, then there is a, so some of these are suitable for decorative purposes and they are surface mounted. They can be vertical, horizontal, and these particular examples which are taken, they are useful for providing what are called as CFL or compact fluorescent lamps. On the other hand, the consumer luminaires meant for fluorescent lamps with surface mountable are shown in this picture, as the left one is an open batten type with all the accessories shown. the right hand side you can see the accessories are enclosed, but the lamp is naked, whereas the third one you have a diffusing cover placed. These are some decorative downlighters using compact fluorescent lamps. These could downlighter, we call it a downlighter because when you have a narrow beam and direct it directly on the task surface, as we talked about having that in case of a high bay industrial application. These are commercial luminaires using CFLs suitable for recessed mounting. In fact, I was telling you creation of what is called as a sheet of light would be the ideal thing, because where you can mounting height becomes independent, and most luminaires adapted are for using more than 2 lamps these days with mirror optics, and some of these, though it says CFL, similar luminaires are available for even normal fluorescent lamps or energy saving fluorescent lamps. Now this is a picture which shows spectrum of lamps that are available, right from incandescent lamps, compact fluorescent lamps, and therapeutic lamps, and all kinds of lamps. One could see fluorescent lamps of various shapes, circular, and U-shaped, etc. So this is some of the pictures. Now, having said all this, I said there is recommendations have been obtained, and these are all based on the CIE recommendations, which are adapted by the national standards, and therefore we would like to mention some of the standards. I must emphasize here that each of these standards has more than one part. It's briefly mentioned here. As can be seen, vocabulary, electrotechnical vocabulary for lighting is given in IS 1885, whereas the recommendations required for street lighting, in fact if you see carefully, though I have titled it as street lighting, it talks about recommendations for thoroughfares, that means streets, roads, etc., is in IS 1944. Lighting for ships, which though we have not really covered, is included in IS 2592, it's onboard lighting. Libraries are places, large reading rooms, so IS 2672. Hospitals, we did mention hospitals have 3 categories of users where the lighting requirements could be based on the user requirement. Patients require low lighting to be able to relax, whereas the technicians and doctors require higher levels. IS 4347 gives the recommendations for hospital lighting. Continuing with the recommendations, the one aspect which we said is the lighting photometric standards are covered in 7678. Now, in fact, airport itself is a big industry, and airport lighting requires considerable amount of integration of various kinds of lights. These are covered in IS 7785. Dam lighting is covered in IS 9297, and we did say wherever there are large number of people involved, there should be some form of emergency lighting, which is covered in IS 9583. Educational institutions, we had a look, IS 10894. This is not the exhaustive list of standards, but these are some of the standards which relate to the recommendations which we have tried covering in this course, and which are taken based on the CIE recommendations, and most of these are in consensus with CIE, adapted for our local conditions. And I must re-emphasize that these are not the exact titles of the standards, though they cover recommendations for that particular task or that particular application. So in total, the summary is industrial lighting is dictated by the nature of work, shape of space, and the ceiling structure. It could be classified as single story without skylight, multi-story, single story with skylight, high bay light. And continuing with the summary, additional lighting are used if general lighting doesn't meet requirements, illuminating by magnifying glass, stroboscopic or monochromatic light. Fluorescent lamps with lowers and diffusers are preferred for office lighting, and vertical illumination is very important in auditoria and educational institutions on the chalkboards or blackboards. In shops and restaurants and commercial places, local and color lighting is employed to highlight a product or a place. In hospitals, lighting is done according to convenience of patients, technicians and doctors. Operation theatres need shadow-free lighting. ICU and X-ray rooms have very low illuminance levels, and some of the Indian standards for lighting applications have been mentioned in this lecture. Details can be had from the handbook of BIS, and these are mostly adapted from CIE. Coming to the tutorial questions, when do you need stroboscopic lighting? What care should be taken for auditorium lighting? How should the line of luminaires be mounted in industries and why? Answers to questions in the previous lecture. What do you mean by surface reflectance of 7751 and 751? It means 7751 means surface reflectance of ceiling is 0.7, frieze is 0.7, walls 0.5 and work plane is 0.1. In fact, frieze is the wall surface over the plane of mounting lamp, whereas when they are recessed in the ceiling, 751 is what it means. 0.7 for ceiling, there is no frieze, walls 0.5 and work plane is 0.1. Work plane or the floor always has very low reflectance. What are isolux diagrams? Isolux diagrams used for calculation of illuminance and luminance levels. The equal lux level, equal illuminance curves. What do you mean by frieze? Frieze is the wall area above the luminaire plane, that is the plane at which luminaires are located. Thank you.